Welcome. Today in lab we will be synthesizing and analyzing benzocaine. In this experiment we will use a Fischer esterification reaction. We will begin by reacting para-amino-benzoic acid with ethanol in the presence of an acid catalyst to create benzocaine. Now this reaction is reversible. So to ensure that we create enough benzocaine, we're going to use a large excess of ethanol. This takes advantage of Le Chatelier's principle. By overloading one side of the equation with reactants, we can ensure that the reaction is driven to completion and we create enough benzocaine for us to analyze. Here's a list of safety precautions specific for this lab. Use caution when using the sulfuric acid, and make sure you dispose of all waste properly in the hood, and as always, wear your PPE. And with that, let's begin the lab. We will begin by weighing out our para-amino-benzoic acid. Weigh the acid out on the analytical balance. You want to get close to 1/2 gram, but it doesn't have to be exact as long as you know how much you weighed out. Once you have weighed out the para-amino-benzoic acid, transfer it to your 25 ml round bottom flask. Return to your hood, and you're going to add 7 ml of ethanol to your round bottom flask. Measure the ethanol out using a 10 ml graduated cylinder. Lastly, we will add the sulfuric acid. Measure out 1/2 ml of the concentrated sulfuric acid. Be careful while you're doing this. Your instructor may be the one that adds the acid. You may measure out the acid with one of the plastic disposable pipettes. The exact amount is not important, it just has to be about 1/2 ml. Once you have added the acid to the round bottom flask, close up the system and begin your reflux. Here you see a picture of our setup for the reflux. Notice that cold water enters the reflux condenser from the bottom and it exits at the top. The heating mantle is plugged into the variac, which is set at either 80 or 110 volts, depending on what model of variac you have. Once the reaction is boiling, you begin to see the reflux happen. Here you can see the condensation ring on the condensation column and the liquid flowing back down into the reaction flask. After refluxing for 45 minutes, turn off the variac, remove the heating mantle, and allow the reaction flask to cool down. Once the flask is cool, remove it from the apparatus and pour the contents into a 100 ml beaker. Now we will begin to isolate the crude benzocaine. Add sodium carbonate slowly with stirring in between additions. You are trying to raise the pH of the solution up to about pH 9. You will see in this example that we added some sodium carbonate, checked the pH, which was about 7, and then added a little more until we reached pH 9. Once the solution is at pH 9, add 10 mils of distilled water to your solution. Then you will place it on an ice bath to begin crystallization. After crystallization is complete, use vacuum filtration and the Hirsch funnel to collect the crystals. Make sure you dry the crystals for at least 5 minutes while you're doing the vacuum filtration. While the crystals are drying, heat distilled water on the hot plate. Once the crystals are dry, transfer them to a 25 ml Erlenmeyer. Then add 3 mils of 95% ethanol. Place the Erlenmeyer on the hot plate and begin dissolving the crystals. Add 5 mils of the heated water in 1 ml increments until the crystals are all dissolved. Then place the Erlenmeyer in an ice bath so that crystals may reform. Once the crystals are dissolved, remove the Erlenmeyer from the hot plate and allow the Erlenmeyer to come to room temperature, about 5 minutes or so. Then place the Erlenmeyer in an ice bath to reform the more purified crystals. Now you will refilter the purified crystals, again using the Hirsch funnel and vacuum filtration. Transfer your crystals to the balance to get an accurate mass so that you can determine percent yield. So all those safety lectures are going to be on the internet now, and he's not going to have to come into the lab and do it. That makes me so much happier because it's not going to kill an hour of lab for them. Like they'll check in, they can walk right in and start doing it. Perform the thin layer chromatography assay. Take a TLC plate, draw a line about 1 centimeter up from the bottom. Make 3 marks on the line. Here you will spot your initial para-aminobenzoic acid starting material, a pure benzocaine standard, and your benzocaine that you have made. Place about 3 to 4 mils of the TLC mobile phase, which is 1:1 hexane ethyl acetate, in the bottom of the TLC chamber. Place a few crystals of your benzocaine on a watch glass and dissolve it with a few drops of acetone, no more than 10. Use this solution to spot your TLC plate. You will also spot the para-aminobenzoic acid standard and the benzocaine standard that will be provided to you. When you are spotting your analytes on the TLC plates, you do not need a lot of material. A few touches from the micropipette to the TLC plate will put more than enough on for your analysis. Once you have the TLC plate spotted, place it in the chamber and let it develop for a few minutes. You will know that your TLC plate has completed developing when the solvent front has stopped moving up the plate. Once that is completed, you can remove the plate and let any solvent on it evaporate. Immediately after removing the TLC plate from the chamber after it is done developing, draw a line across the top of the solvent front. You will need this to calculate your RF values. Place the plate under a UV light so you can visualize the spots. Again, in pencil, draw circles around the spots lightly so you do not damage the plate. You will also obtain the melting point of your product. Using one of the melting point capillary tubes, pack a few millimeters of crystals into the tube and place it in the melting point apparatus. Begin heating the melt temp at the rate of 1 or 2 degrees per minute. Keep an eye through the viewing port on your sample. When the sample begins to melt, record that temperature. When the sample is completely melted, record that temperature. This will give you the melting point range of your product. Your final analysis of your product will be to obtain the IR spectrum of it. Using a spatula, place a small amount of your product over the window for the infrared spectrophotometer. Then lower the anvil to compress the sample against the analysis window. Once that is done, using the software, start your analysis. Once you have obtained your spectra, make sure you print it off. You will hand the spectra in with your lab report. Make sure you label all relevant peaks. You will also hand in your melting point range, your percent yield, and your results from your TLC analysis of your product, highlighting all relevant RF numbers of your starting material, the standards, and your product.